All right, welcome back. This is lecture 9 of CS164, and after today we only have 2 lectures left. So next week we'll have our guest lecture on Windows Mobile and things related there too from a friend of ours, Edward Guarin from Microsoft. The week after we'll talk about issues of security, and then that's it. And then the few weeks after that we'll regroup after in the midst of you're working on and finishing up Project 3 for the SES Design Fair. So this is going to be a new thing this year, modeled in the spirit of the CS50 Fair, but meant to be inclusive of a whole bunch of classes, taking up multiple floors in Maxwell Dworkin. So more details on those in a few weeks, but the idea is that we'll have 1 or more time slots during that day. It's the first Tuesday during reading period. And the goal will just be to exhibit the projects that you guys and other classes have done this semester, particularly the choice of student projects. So more details via email. Today's meant to be a conversation about scalability. So especially when you're taking software courses in school, it's a little easy to get in the habit of just being handed things like an appliance or an account on a Linux server. And when you then finish up a course like this or some other course, it's not necessarily always clear how you can go about actually using those skills in some other environment. And particularly if your goal is to support some large number of users, to spin off some startup of your own, you yourself are going to have to figure out, do you buy a server, do you rent a server, what are the technologies you need to choose from, because obviously you'll no longer be handed a PDF that tells you what to do. So today is really meant to be a conversation and a design discussion about the kinds of larger scale issues you might have to decide on besides just the PHP framework, besides just the mobile platform you're choosing. How do you actually scale server side to support increasingly networked services? So with that said, suppose that you are trying to make an iOS app at this point in the term, or a few weeks back, a web application that needs to talk to some server. So Abel Hangman does not need to talk back to some central server, but maybe Project 3, your student's choice, will need to have some kind of server interactions. And certainly a web-based application, mobile or not, needs to talk to some server. So you finish up this course in a few weeks. Suppose you graduate college, you want to go start some company, or you want to go work for some software type company, and the goal is to have a web server. How do you go about procuring a web server so you can write your PHPs and your Pythons and Ruby somewhere on the internet? Literally, what do you do? Yeah.
Buy a VPS from a web host.
Okay, good. So there's this notion of a VPS. Some of you who took 50 might have recall some of these details or read up on them toward the end of that semester. So a VPS, virtual private server, what does that actually mean? What's a VPS? Yeah, Carl.
So we have like a bunch of boxes in some like farm somewhere.
Okay.
And then this is meant to have like space inside those boxes.
Okay, yeah, so there's some commercial vendor who, him or herself, actually owns a bunch of servers, and typically using virtualization software like VMware or something similar to VirtualBox, but for a server environment, chops up that hardware into the illusion of multiple servers and then rents to someone like Carl the illusion of an actual server, a virtual server, in that Carl would have root access on it, an administrator account. He could install anything he wants on that server, but there are some gotchas. If you're using a VPS and you're paying someone $20, $50, $100 a month for a VPS, what do you need to beware based on that definition? Sounds great, right? Yeah.
There's other people on the same physical hardware.
Yeah, so there's other people on the same physical hardware, and it's certainly in the commercial entity's commercial interest to perhaps oversell their resources. So if they have, for instance, a 4-core machine, effectively 4 CPUs inside of the machine, it might be reasonable to slice that machine up using virtualization software into 4 virtual servers, each one of which gets a dedicated CPU. But suppose that one or more of the customers on that box really aren't that active, or their websites aren't that popular or that successful, don't get much traffic. So, it might be reasonable to run 5 virtual servers on that 4-core machine, or 8 virtual servers on that 4-core machine. And using virtualization software, you can still multi-thread things in such a way that everyone gets an equal fraction of the CPU. It's not a problem that you're sharing 4 CPUs over more than 4 virtual servers, but the implication is that suppose that one of these people gets their website linked on Reddit or Slashdot or something like that, and all of a sudden they get tens of thousands of hits one day. Well, what does it mean for the n-1 other customers on there? Right, they too might suffer. So there is perhaps a dependency there, even though the price tag of $20, $50 a month might be much more attractive than a $6,000, $3,000 physical server. So what else is there to be mindful of with a VPS, or what are alternatives to it?
You'll probably have to pay extra for a dedicated IP. So you have to
Good.
pay extra for SSL or something like that.
Okay, good. So you often have to pay a few dollars more a month for special services like a dedicated IP. And you pretty much addressed why you might want a dedicated IP. SSL effectively requires that you have a unique IP address because of the encryption involved. And long story short, if the data is encrypted, the server can't figure out whose website you've requested until the HTTP request has been decrypted. But if you don't know who the request was for on a multi-host system, you don't know whose encryption key to use. However, if you have a dedicated IP address for a site, you can just assume blindly that anything coming in on 1.2.3.4 is for CNN.com or whatever the company actually is. So for SSL, you have to pay a bit more. Other qualms or alternatives altogether? Yeah?
You might not actually use all the resources that you buy.
Okay, so you might not use all the resources you buy, or that you'd be buying, right? You might get some number of terabytes of traffic per month, which you don't really need. You might get some number of gigabytes of storage space, more RAM than you actually need. So in fact, there are more cost-effective solutions than a VPS, and most VPSs start, around the $50 per month mark. And if it's any less than that, you need to then start questioning, frankly, who the vendor is and to what extent they're oversubscribing. But you can have a more generic web host, right? And this is what cloud.cs50.net was in CS50 for those who took it when we had the cloud. And it's the one server, effectively. And everyone doesn't have the illusion of a machine on it. What does everyone have on a web host?
A directory.
So a directory. You have a home directory. You have a username and password. And that gives you the ability to actually host your content on someone else's server. But the downsides there include what? Yeah. You don't control the server, right? If you actually want some new Python library installed or PHP module installed or MySQL upgraded, you have to email the system administrators and ask if they will do that for you. And typically they won't because you are not the only one on that machine. And doing something for you could be to the detriment of other people who might be relying on certain versions or might certainly not want to deal with the headaches of upgrades. So commercial hosts often do trail in terms of the versions that you're using, and certainly you have your less flexibility. So a common question toward the end of a semester is what web hosts could we use, should we use? This, frankly, is very much a religious thing, and you can ask a dozen people and get a dozen different answers. In 50, at least, this was a recurring theme when we asked people, who do you use, who do you like? These are some names that you're welcome to Google. We've used some of these ourselves, and then in the VPS realm, these are some of the more popular folks. But if you're really kind of itching to learn more about system administration and running your own servers, actually signing up for a VPS or just running your own VM on campus, and you can request of Hewitt a dedicated IP address. If you own a desktop and you want to be able to connect to your own dorm room from some laptop on the internet, you can make that happen. Realize that at least playing with a VM, whether running on your hardware or someone else's, is a nice way to experiment. And Linode and a couple of these others are actually fairly cheap, but I wouldn't necessarily start a company using those, but it's nice if you just need an external server for whatever purposes. So if you need a server, you start Googling around for things like this, but unfortunately this only goes so far, right? Suppose that your website becomes quite popular, and so your one web hosting account doesn't suffice, or your one VPS doesn't suffice. So what are your alternatives? Suppose you very happily are getting successful and getting thousands of hits now per minute or per second even. Yeah, okay, so you have a bigger fish out there. So you have Amazon Web Services, AWS, and they have one service called EC2, Elastic Compute Cloud. And this is a more genericized version of this, whereby you don't have to go to a website, fill out a form, wait for a human to actually provision, so to speak, your VPS by actually clicking some buttons or running some commands. Rather, Amazon is really a self-service VPS architecture. And so simply by logging in to Amazon's website and by associating a credit card with your account, you can literally click a couple buttons yourself and within seconds have one VPS up and running, have 10 VPSs up and running, have 100 VPSs up and running, and then with a simple click can you shut all of those down. In fact, a few years ago when Amazon first released EC2, one of the neatest stories in the newspaper that I found was a story by a fellow at the New York Times who had like gigabytes worth of TIFF images, TIFF, of old newspaper articles from the New York Times, and they needed to digitize, well, they had already digitized these things by scanning them, but they, I think, needed to do something like OCR en masse on all of these things. And they had the software, but they didn't really have the hardware. And to do this efficiently would have required dozens and dozens of servers to be configured, to be powered on, to be connected to a network. And then after his project was done, they didn't really have a compelling need to keep a few dozen or whatever it was, 100 servers around. And so around this time, EC2 was getting popular. So this fellow spent a few days writing some software that would iteratively briefly go through all of the images, digitize them, or do whatever he needed to do, and then quit. But then what he did was leverage EC2 and spawned, I think, 100 or so EC2 instances, and within 24 hours had digitized dozens of years worth of content, powered it down, and it cost a few tens, a couple $100 instead of literally tens of thousands of dollars. And so things like EC2 really let you scale, not just for one-time projects,